All right, so this is the second half of the 10-7 video. So if you haven't watched the first half, please do that before you do this. But if you have, you're in the right place. All right, so we've been talking a lot about the standard equations of circles, okay? So if we look at here at example 5, it says prove or disprove that the point square root of 2 lies on a circle centered at the origin containing the point 2, 0. Okay, so we know it's centered at the origin. So we know that when we talk about equations of circles, we need the center, which we have the origin, and we need the radius. Okay, so it's centered at the origin and it contains the point 2, 0. Okay, so from this right here, if it's centered at the origin and contains the point 2, 0, that means the radius of the circle must be 2. Okay, now we want to know, does square root of 2 lie somewhere on that circle? Okay, well guys, we can't graph this and then look because square root of 2 is not nice numbers. So for now, we're just going to forget that this exists. Okay, we'll get to that in a minute. Using the center and the radius, using what we know of the circle, we're going to go ahead and write the standard equation of it. Okay, so it's x minus the 0 squared plus y minus the 0 squared equals 2 squared, which is 4. Okay, so if we simplify it, this is just x squared plus y squared equals 4. All right, now, using the square root of 2, this is an x value and this is a y value. So if this lies on the circle, then we replace square root of 2 in for x and square root of 2 in for y. This should hold true. Okay, so let's check it out. So we're going to replace square root of 2 in for x, so square root of 2 squared, plus for y, we're going to replace it with this square root of 2. Square root of 2 squared equals, I'm going to put a question mark, 4, because we don't know if they're equal or not. If they are equal, it lies on the circle. If not, they don't. Okay, so square root of 2 squared is just 2, plus square root of 2 squared is 2. Does that equal 4? Yes, it does. So yes, we've just proved that it lies on the circle. All right, I want you guys to go ahead and do example 6 on your own, and then we'll go over it. I highly encourage you to draw it because it will help. All right, so in order to write the equation, we need the center, which we know is at 1, 4. So here's the 1, here's the 4. And we find the radius by graphing it because we know 3, 4 is on the circle. And this is the center, guys. We can just count 1, 2. So our radius is 2. So x minus, our 1 is right here, squared plus y minus 4 squared equals our radius squared, which is 4. All right, so let's look at example 7. And the way we're going to do this, it's not ideal. Normally, in a normal COVID year, or in a non-COVID year, we'd be doing lots of constructions with compasses and things like that, and we would do this with a compass and would get a nice, beautiful answer that works. But since we're not doing that, and I don't have the capability of using a compass on here, I'm just going to have to use some digital stuff that draws circles for me. So it'll be a little rounded and it probably won't come out perfect, but it'll work. All right, so this is truthfully how we locate earthquakes, okay? So in example 7, it says the epicenter of an earthquake is the point on the Earth's surface directly above the earthquake's origin. A seismograph can be used to determine the distance to the epicenter of an earthquake. Seismographs are needed in 3 different places to locate an earthquake's epicenter. Use the seismograph readings from locations A, B, and C to find the epicenter of an earthquake. Okay, so the first one is that it is 7 miles away from -2, 2.5. All right, so what I've done is I've used this, it's called GeoGebra, and I've plotted a circle, and it's really hard to get exact. That's roughly, the center's roughly -2, 2.5. that has a radius of 7. So the epicenter could be anywhere along here. Okay, so now we go to the second one. Okay, we know that there's an epicenter that's 4 miles away from B is 4, 6. Okay, so what I've done is now I've gone and I've drawn a circle that's centered at 4, 6 that has a radius of 4 miles away. So the epicenter has to be somewhere on this circle as well. So if you can see, there are 2 points, this one here and this one here, that satisfies the first 2 stipulations. All right, so now let's look at the third stipulation. Okay, so the epicenter is 5 miles from 3, negative 2.5. All right, so if I plot that circle, that would be this bottom one here. The epicenter has to be somewhere along here. Okay, now there's going to be one point, like I said, this isn't exact, but it's pretty darn close. There has to be one point where all 3 of these circles intersect, and it's right around this point here. Okay, so somewhere there would be the epicenter of the earthquake. And like I said, this is really how they determine where epicenters are.